We're on 2.2, B as in boy, and I'm on page 120, middle of the page under letter B called revenue. Now, in a previous section, we talked about profit being equal to revenue minus cost. And if you remember from that conversation, revenue is the amount of money that you make off a product minus the cost to produce that product equals your profit. So if I sold a set of JBL noise canceling earbuds for $100 and they cost me $20 to make, doesn't that sound normal? My profit would be $80, 100 minus 20. So that's what that looks like here. So I'm going to leave that up there, and we're going to go into example number 5. So we've got this manufacturer of small calculators, and this manufacturer, let's call them Bud. They know that the number of calculators Bud can sell each week is related to the price, meaning that the more expensive the calculator, the fewer they're going to sell. The cheaper the calculator, the more they're going to sell. So there's a price point where they can sell it for a certain amount and sell it for a certain amount and be able to make the most money possible. So here is the formula that they give us. Again, you don't have to understand this formula. You just need to know how to use the formula. So x equals 1300 minus 100p, where x is the number of calculators, the problem says, and p is the price per calculator. So what should Bud charge for each calculator if Bud wants the weekly revenue? We want the revenue to be $4,000. So Bud doesn't want to make $4,000. Bud just wants to sell $4,000 worth of calculators, and then we will subtract whatever Bud's cost is to find out what the profit is. So here we go. The revenue, the amount of money that Bud makes, is going to be equal to, so let's come up with a formula here. The revenue is going to be equal to the number of items sold times the price per item. So his revenue on calculators, if he sold 100 of them at $5 a piece, his revenue would be $500, 100 times 5, and that's what we're looking for there. So what we're looking for in the problem is we want wrong button. We want a revenue of $4,000. So if we use R equals the number of calculators sold, and we'll call it X because that's the number of calculators sold, times P, and P is the amount of money they made off each calculator. That would give me the revenue. Well, what did they tell me? They told me that X equals that. So what I'm going to do is I'm going to replace X with that. So I'm going to get R equals 1,300 minus 100p times this P. And that's what my revenue is going to equal. So let's go ahead and see where we can go with this. I'm going to move this up here except for that problem or that equation that we have here. So what do we want to do? We want to find out P, how much profit we have when R is 4,000. Or I'm sorry, not the profit, the price. So we're going to do some switching around a little bit. What is our revenue. Our revenue is $4,000. That's how much money Bud wants to make off these calculators. And then we've got our 1,300 minus 100p times p. So let's go ahead and distribute this p here and here. So we have $4,000, or 4,000 equals 1,300p minus 100p squared. So we're going to just keep going. We're looking for p. All of our variables are gone. All we have left is p. So what I'm going to do is I'm going to set this equal to 0. So I'm going to subtract 4,000 from here and subtract 4,000 from here. So I've got 0 equals 1,300p minus 100p squared minus 400. All right, the way that is set up makes it a little bit tricky. So what I'm going to do, we're going to switch. We're going to move the 0 over here instead of over there. Okay, that makes it a little bit easier. Now I have to set this up so that it's in the right order. So I'm going to move this to the front because it's got the p squared. And then I'm going to put 1,300p minus 4,000 equals 0. Now I don't like my lead term to have a negative, so I'm going to switch them all. Change that to a positive, this to a negative, and that to a positive. And I've got a quadratic equation there, and we're ready to go. So first of all, what I'm going to do is I'm going to pull a 100 out of each term. So I'm going to divide this whole thing by 100 and this whole thing by 100. And when I do this, I get 100 over 100 p squared minus 1,300 p over 100 plus, sorry, I'm just kind of going through here pretty quickly, but 0 over 100 is 100. What I'm trying to do is get rid of the term in front of the p squared, because 100 over 100 is 1. 1,300 over 100 is 13. 4,000 over 100 is 40. And we're here. Okay, so this here equals the same here. It's kind of like we just reduced it. All right, at that point, we can divide this into two binomials, make it equal to 0, have a p as the first term. And I'm going to find two numbers, multiplied together, give me 40, added, give me 13. And in this case, it's 8 and 5. 8 times 5 is 40. 8 plus 5 is 13. We have a negative here, though. So it has to be a negative 8 plus a negative 5 gives me a negative 13. Negative 8 times negative 5 gives me a positive 40. And then what we've been doing before is setting each one of these equal to 0. So p equals 5 or 8. So what this tells me is she can sell the calculators for $5 or $8. And if she were to do that, she would have her weekly revenue of $4,000 like she wanted. So you're asking, well, how in the world can that happen? If she sells them for $8, she's going to make more than if she sells them for $5. Well, like I said earlier, if she sells them for $8, she's going to sell fewer and then make $4,000. So she's only going to sell 500. But if she sells them for $5 a piece, she will sell more but make less. So she will sell 800 here to make 4,000. So that's why you've got two different values. So continue on, top of page 122, example 6. We're given a formula, P equals 2W plus 2L. and they want us to solve for W. So what that means is they want us to rearrange this problem. So instead of P equals 2W plus 2L, it says W equals something. So what we're trying to do is we are trying to isolate this W so it's the only thing on one side of the equal sign. So we just start whittling away. We minus 2L from this side. We have P minus 2L equals 2W. Okay, that's not too bad. Now we've got to get rid of this 2 right here. So let's go ahead. It's multiplied by the W. Let's divide it by the W. So both sides have to be divided by 2. That cancels out, and we get P minus 2L over 2 equals W. And that is it. I had mentioned earlier about a formula that looks like this. And that is distance equals rate times time. So distance equals speed times time. So how that works is, let's say you're driving to Anchorage and you're going 60 mile an hour. That's your rate. And you're driving for 2 hours. Whoops, let me put that right. Your time is 2 hours. Now, according to our distance equals rate times time, if we multiply our speed times how long we're driving, we will get how far we went. 60 mile an hour times 2 hours gives us 120 miles. So that's our distance. Sometimes we know that the distance we want to drive is 150 miles. And let's say that we have 3 hours to get there. I want to know how fast I need to go. Well, I divide both sides by 3, and I get 50 equals the speed I need to go, so that if I drive that speed for 3 hours, I get 150 miles. So this formula here is very, very important. In fact, it can be written several ways because you may be needing it for different things. So, for instance, the rate, how fast you're going, equals the distance over the time. So back in the olden days, before we had computers and all of that, if you wanted to find out how fast you were going, you would use your odometer, and you would find out your distance. So let's say you went 2 miles, and you did that in a certain time period, like maybe 2 minutes. That means that you went 60 miles an hour if you're able to go 2 miles in 2 minutes. So sometimes you're going to write the formula R equals D over T. Sometimes you're going to write it as T equals D over R. So there are your 3 formulas, and we're going to go ahead and do some examples based on this. So if we were to look at example number 7, it says the first Ferris wheel was designed and built by George Ferris in 1893. We don't care about that. We're just trying to solve the problem. The diameter of the wheel was 250 feet. So the diameter is the distance from one end to the other that goes through the center. So it's 250 feet. It had 36 carriages. So we go around here, they're equally spaced, and we get 36 carriages. There are 40 people that can ride on this. One trip around the wheel took 20 minutes. So if you were sitting here and you went all the way around, it took 20 minutes. Holy cow, that's like barely moving. Find the average speed of a rider on the first Ferris wheel. All right, so one of the things that's really important is we were given a lot of information. We were given the diameter. We were given 36 carriages. We were also given 40 people, and that a trip around the wheel took 20 minutes. So we're given a lot of information, and not all of it is necessary. What we do want to know is, in order to solve this, we're going to use the distance equals rate times time, or rate equals this, or one of these formulas. That being the case, there is a D in all three of those, and that's distance. So that means we have to find the distance from here all the way around to here, because we do need a distance in there somewhere. If you remember from a long time ago, you should have a formula that the circumference of a circle, the distance around the circle, equals pi times diameter, or C equals 3.14 times 250 feet, because that's the diameter. Okay, that being the case, the circumference equals right around 785 feet. So the circumference, or the distance, whichever you want to call it, in a circle is called circumference, but that is the distance. To find the speed, we're looking for this one, right? Because we're looking for the rate. So right now we have rate equals the distance over the time. How much time do we have? It took this guy 20 minutes to go all the way around there. So we're going to put 20 minutes underneath, because in this problem here it's time. Okay, we divide this out and we get the rate equal to 39.3 feet per minute. That's the speed we end up going, because this is in feet and this is in minutes. We could have used conversions and made this miles per hour, but we're only interested in getting the speed, and given the information we have, we're not going to change it to miles an hour. All right, so that is example number 7, and we will do a C video to go through 8, 9, 10, and 11. And those are not too terribly bad, so they should go pretty quickly.